Welcome to the second episode of Let's Talk Science, the podcast where two PhD students bring you the latest science news on COVID.
So I'm Stephanie Monticelli, and that's Daphne Pariser, and we're your hosts today.
And today we have a very special guest with us. His name is Ben Miller. And so Ben actually got his PhD in chemistry from Stanford University. And following a stint as an NIH postdoctoral fellow at Harvard in Stuart Schreiber's lab, he joined the University of Rochester as a faculty in 1996, where he is currently the Dean's Professor of Dermatology, Biochemistry, and Biophysics in our Biomedical Engineering and Optics department. He is also the founder of several different organizations that we're going to talk a little bit about today that are actually working on some similar things like rapid diagnostics. So we're very, very excited to welcome Ben Miller.
Thanks, Daphne and Stephanie. Great to be here with you today and great to talk with everybody.
Yes, thank you so much for being here, Ben. So I guess we'll start first by kind of asking you to explain what exactly a rapid diagnostic is for some of our audience members who might not, really know what a rapid diagnostic does.
Well, rapid diagnostic is basically a way to very quickly tell you whether you have some sort of disease or whether you've had a certain disease in the past. And we work on both aspects of those things.
And so can you tell us if there are really any rapid diagnostics that are currently being used for COVID?
Well, there are some that are beginning to appear. Most of your listeners will probably be familiar with the pictures they've seen of people sitting in cars and then someone holding up a swab and putting that up your nose. That's really not a rapid diagnostic in its current form, in that somebody has to take the swab and then go and process it in a laboratory to eventually provide an answer. So there are now some tests where potentially you can just spit in a cup and then that can quickly provide an answer. But I don't think we're yet to the point that you can give some sort of sample of body fluid and quickly, meaning in 5 or 10 minutes, have an answer as to whether you have COVID-19 or not. The other thing that certainly people are very interested in knowing is whether they've had COVID-19 in the past.
Right.
And so those kinds of tests, which are what are called antibody tests, basically finding out whether your body has had an immune response to COVID-19.
Right.
There are some of those now that are rapid, but one issue is that there have been so many of them developed and deployed that the quality is highly variable.
Mm-hmm. And I want to take just a second to step back a little bit and kind of talk a little bit about what the difficulties are in terms of, so right now, the tests that we're using, why is that not considered a rapid diagnostic? What exactly are the difficulties that are standing in the way of making something like that a rapid diagnostic?
So let's say that I want to directly detect the COVID-19 virus.
Mm-hmm.
Then I have to sample the virus from wherever it is. For example, that's the swab now. But then I've got to break open the virus and get at the genetic material that's inside it. And since there's usually not a lot of that material available, I have to amplify it in some way. So right now, the tests that are being done sequentially do each of those things. And different people even will do each of those things. And that is what contributes to it being a lengthy process. So you basically have to have a way that all of that sampling, processing to get at the internal genetic material, and then amplification can all happen in one unit.
Mm-hmm. And so how are people trying to make that different for the rapid diagnostic and specifically now the antibody test?
So for the antibody test, many of your listeners may be familiar with pregnancy tests. And that's something that's called a lateral flow assay. It's detecting a particular chemical or antibody or hormone. There are all kinds of versions of this. It's just basically a little strip of paper with an indicator that lights up if an antibody is present. And so people have worked out ways of doing this for COVID-19. One of the cautions, though, is that in some cases, the tests that have been developed can't discriminate between the COVID-19 virus and common circulating coronaviruses that cause colds, which many of us have.
That is a huge problem.
So you bring up the antibody tests. So some of our listeners might be wondering, what's the difference, in terms of being diagnosed with COVID between using a rapid diagnostic that actually detects the virus versus detecting antibodies? What are some of the challenges in actually, tracking COVID or contact tracing, things like that for those two different types of tests?
Yeah, so detecting the virus is something that you can do when someone has an active infection and can be done essentially immediately at the onset of disease. When you get a viral infection like COVID-19, it takes your body a little while to ramp up the immune system and start making antibodies. So you really don't have much antibody that's detectable until a couple of days after the onset of disease. And then what happens is that the amount of antibody that's present in your bloodstream will increase to a certain point, and then that level remains high and stable for a period. For COVID-19, it's not clear how long it stays up. That's certainly something that we want to know and is the subject of active research.
Right.
But what that means is that for an antibody test, it doesn't help you detect that you have active disease in the very early stages, but it does tell you over a long period of time that your body has had a reaction to being in contact with the virus and has a certain level of immunity against the virus.
And so why is that important for us to know in terms of developing a rapid diagnostic for antibodies?
Well, so we know that having those antibodies in our blood means we have a certain amount of immunity to getting infected with COVID-19 again. This is certainly subject to active research. We don't know exactly how protective it is, but the idea is that, let's say that I could just take a finger stick of blood and get some information about how many antibodies to COVID-19 I had. If that number is really high, then I don't have to worry about being around other people that may have active COVID disease, because if I have that immunity, I'm not going to get sick.
Gotcha. Well, that sounds really important.
Yeah, it could be. And so this is something that potentially you'd want to have in your workplace or at home as a way to just monitor your ability to go out and interact with people in the community.
So I know that your lab is doing some development, and I know I'm skipping ahead a few questions, and we'll definitely get back to some of our other questions, but I know that your lab is actually developing this similar to a pregnancy test, also known as lateral flow assay, for the antibodies for COVID. So do you want to tell us a little bit about how all of that works? And I'm also very interested because I know that these tests for COVID right now, they require a lot of really heavy machinery and trained staff, and it's really expensive. And so with your product, does that change anything because it's on a more simple, assay, and kind of talk us through that?
Right. So right now, we're doing our initial development of diagnostics using some optical sensor platforms we've developed. So we're not quite to the lateral flow assay yet, although we hope to get there. But we're focusing on being able to make tests that can discriminate antibodies to lots of different viruses. So not just COVID-19, but also other coronaviruses like SARS and MERS. And then all of these different circulating coronaviruses, common cold viruses, and flu viruses, which we've spent a lot of time working on. So having all of those on a little chip, actually, here's one of them right here.
Oh, awesome.
So this chip has actually 400 spots on it.
And so for those of the people who are just listening, he's holding up a chip that is probably the size of like less than half of my fingernail, and it's black and it looks beautiful. Okay, keep
going. And so all you have to do is put a blood sample on that, wait a little bit, and then we have an instrument that will read off how much antibody is present for each of those spots on the chip.
Wow.
That's going to tell us a lot of information about do we need all of those things when we do transition to something that's a lateral flow assay? That is, what are the important components that we need to monitor? But it's also going to tell us about the relationship among these different viral diseases and how people with immunity to flu, for example, may respond differently versus people that have less of an immunity to flu if they get COVID-19. So there's a lot of interesting basic research we're doing there too.
Well, and it also sounds really important because then you don't have to reorder, 100 different tests to make sure that they don't have influenza versus COVID. So you can do it all right in one space. So that's amazing.
Yeah, that's exactly what we want to do.
Okay, so we're going to take a real quick break. So we have a few announcements. So one is Humans for Education is doing these podcasts because we are actually doing an emergency feeding response right now out in Kenya. So anybody who is interested in helping our feeding response, please feel free to go to humansforeducation.org/COVID-19. You can help sponsor a family for as little as $45 per month. And this will feed up to 7 people in the entire family for the entire month. And in addition to that, if you are looking for some stylish and fun masks, you can buy them at Mansaware, and they will be giving 3% of all proceeds to Humans for Education. So thanks for listening, and back to our questions. Steph, what question do you have next?
So now that we started talking a little bit about Humans for Education, as our listeners know, Daphne and I work in Kenya through Humans for Education. And so one question that we think is really important, especially for developing countries, is, why are rapid diagnostics and even, testing for things like COVID so important for developing countries? And, why is it so important that we get them developed and especially given to developing countries?
Well, so I think a good way to answer that question is for your listeners to think about what happens when their doctor tells them to go get a blood test. Right? Typically, what they'll do is they'll go into some facility, maybe at a hospital, maybe at a clinic. They get blood drawn. That blood is then taken to a central laboratory facility that uses millions of dollars worth of equipment and very highly trained personnel to several days later produce some sort of answer that comes back to the patient via the doctor. Okay, so it's this really complex process that involves a lot of people, a lot of expensive high-tech equipment, and a lot of time. And I think talking to you folks at Humans for Education, I've gotten some really excellent examples of why that's unworkable in a resource-limited environment, because you have people who have very little in terms of resources and in terms of cash, to put it bluntly. So they can't pay for all this really expensive equipment. You have someone who may have walked for hours or days to get to a care provider. And at that point, they need an answer that can be provided inexpensively and immediately without this network of really highly trained people and really complicated equipment. So figuring out how to make diagnostics that can work in that situation, as well as taking into consideration the fact that there are environmental effects that are important too. Being out in a hot and dry climate or a hot and humid climate. Those are really important things because the people in those situations need healthcare just like we do. Right. And so it's critical to figure out how to deliver that to them.
And so is your lab currently doing any work in terms of trying to deliver rapid diagnostics to developing countries?
Absolutely. I've got students in the lab who are thinking about ways to make that work for viral and bacterial diseases. It's a very active area of research. And it's been exciting because this is something that you begin to talk about it with people and people get excited. And so collaborators join in. And certainly there are people who can provide us with really useful information about what's needed. I mean, that's been a terrific aspect of talking with you to learn what is it that people really need. And, as a scientist, one of the most exciting things to find is when somebody provides you with a really cool problem. And I think this whole area is a really cool problem for scientists to work on, and obviously a really important one in terms of being able to help people.
Well, it's super important.
Yeah, we've talked a lot about costs. So how much is costs for rapid diagnostics going to factor into the ability to actually get these tests to developing countries and low and middle income countries?
So I think it really is critical. It has to be at the point where a cost is around the pennies per test range. Mm-hmm. And I mean, think about the last time that you went and had a blood test done at your doctor's office and how much that cost. Of course, a lot of that is stuff that gets layered on above the cost of the test itself, but really it's important to think about how we can make these things really inexpensive.
Mm-hmm. Right. And then the last question that I have for you is, where are you guys right now in developing your rapid diagnostics for COVID?
So for COVID, we're at the point with the antibody tests where we have tests working on 2 different platforms. We're beginning to get human samples from convalescent patients from the hospital in collaboration with several folks here at the medical center. That's giving us important data about people who've just come out of really severe disease. And what their antibodies look like. I also am in the process of getting an IRB institutional review board approval taken care of so that I can go out and consent subjects independently. Mm-hmm. And then we'll be able to draw from a much broader range of people in the area to say, all right, we know what these really sick people now recovered look like. What does the general population look like? And that's going to be very exciting. And then we also have a couple of companies who are working with us so that when we get to the right point, they can then deploy these assays nationwide.
Awesome. And so what's the timeline for that, do you think?
Timeline. So I think in one case, it'll probably be in the 6-month time frame. For the other, it's going to be sooner than that. I think at least on a limited basis. We know we'll have one facility up and running here in Rochester and then another in St. Louis by the end of the month with a capability of doing, hundreds to thousands of samples a day.
And is that on your chip?
Yes.
Awesome. That's really exciting.
Yeah, it's been a busy few weeks.
Oh, I can only imagine. Your poor students.
I know.
Well, Ben, it's been an absolute pleasure having you on, and thank you so much for, talking with us and just providing us all this really great information. And for all of our listeners, again, if you guys are very interested in what we're doing, we could really use the support. Our families out in Kenya definitely need the help. So please go to humansforeducation.org/COVID19, where you can learn more about how you can do your part in helping out with this COVID crisis. So thank you guys so much, and I really appreciate your time.
Thank you both, and keep up the great work that you're doing.
Thank you, Ben.